Tesla's long-awaited Model 2 is being positioned as a truly affordable electric car, not just because of its lower price tag, but because of the way it is designed to stay cheaper and easier to maintain over its lifetime. Unlike many competitors that must build entirely new production facilities to launch a budget-friendly EV, Tesla is structuring Model 2 so it can be produced on existing lines. This allows the company to avoid the bottlenecks of setting up new factories while still pushing toward mass adoption. Elon Musk's strategy with Model 2 goes beyond affordability at the dealership. It's about minimizing ownership stress, cutting back on hidden costs, and building durability directly into the car's architecture. Tesla aims to achieve this through several clever design choices such as a sealed, rust-resistant underbody, rugged unpainted polymer cladding in high-contact areas, bolt-on crash pods that simplify low-speed accident repairs, modular 48-volt electrical systems, and a consolidated HVAC unit that handles multiple functions while being service-friendly. All of these elements combine to reduce downtime, repair bills, and long-term expenses, making the Model 2 a practical vehicle for mainstream buyers. One of the central ideas behind Model 2 is its three-piece body structure that integrates bolt-on crash pods. The vehicle is divided into front, middle, and rear sections, with modular impact-absorbing elements bolted onto the areas most exposed to urban dings and low-speed collisions. These sacrificial crash pods act as the first line of defense, absorbing energy before it reaches more critical structural rails. This system is not entirely new, as Tesla already employs similar techniques on the Model 3, but the approach becomes especially useful for an entry-level car where affordability is key. By relying on removable crash modules, small accidents can be repaired with simple replacements instead of complex frame straightening. In practice, this means that when a parking mishap or light collision occurs, most of the energy is taken up by these crash pods, leaving the underlying structure intact. Service manuals for existing Tesla models already specify torque values for these connections, such as 16 Nm for bolts linking the crash cans and 75 Nm for bumper beam connections, indicating that standardized replacement procedures are already built into Tesla's ecosystem. Extending this idea to the Model 2 ensures that repairs are predictable and less costly. The ripple effects of this modular crash protection are significant. In today's market, even a relatively minor collision that damages radiators or cooling fans can cost anywhere from $850 to over $6,000, often sidelining a car for extended repairs. Insurance companies, aware of these costs, set premiums accordingly, and in many cases an EV may be written off as a total loss despite seemingly modest damage. By confining crash energy to replaceable modules, Tesla makes it possible to cap repair costs and avoid cascading damage. The result is fewer total loss situations, more stable insurance rates, and less time spent waiting for repairs. Over time, this creates a cycle of affordability where lower costs for parts and labor feed into lower premiums and higher owner satisfaction. It becomes much easier for everyday buyers to not only purchase a Model 2 but also keep it running economically for years, fulfilling its mission as a true car for the masses. The exterior design also embraces this philosophy of practicality with its combination of painted steel panels and unpainted polymer cladding. The upper sections of the car retain painted steel for aesthetic flexibility and color variety, while the lower sections, including bumpers, rocker panels, and wheel arch edges, are covered in tough textured plastic. These are the areas most vulnerable to scratches, chips, and scuffs from daily driving, so leaving them unpainted makes wear far less noticeable. Instead of showing exposed primer or bare metal, these rugged sections hide blemishes, resist corrosion, and require no repainting. If a cladding piece becomes badly damaged, it can be unclipped and replaced without the expensive process of sanding, painting, or blending panels. This small design decision provides outsized benefits in daily life, reducing the stress of curbside parking, grocery runs, and stone strikes, while also preserving the car's resale value after several years of use. Underneath, the Model 2 employs a flat sealed battery floor paired with aerodynamic underbody shields. These shields not only streamline airflow but also protect the car's belly from dust, mud, and road salt, reducing the risk of connector corrosion. Crucially, they feature service hatches accessible from below, allowing technicians to inspect or replace components without removing interior trim. Tesla has already demonstrated such underbody access with the Model 3, where shields are bolted on with standardized fasteners, making maintenance straightforward. This sealed underbody also improves long-term durability, as EV battery packs are typically rated to IP67 standards, meaning they can withstand dust and temporary immersion in water. For owners living in snowy climates, near the coast, or frequently driving on rough roads, this design ensures fewer moisture-related issues and more reliable performance. Beyond protection, Tesla's use of structural battery packs can reduce vehicle mass, improve range by up to 14%, and simplify assembly by eliminating hundreds of parts. Together, these features reduce shop visits, speed up necessary repairs, and enhance the predictability of ownership costs. Tesla is also rethinking the electrical system for Model 2 by adopting a 48-volt backbone instead of the traditional 12-volt architecture. Because electrical power equals voltage times current, raising the voltage to 48 volts reduces current by about 4 times for the same power level. This drastically reduces heat, energy loss, and cable thickness, allowing Tesla to save copper, cut weight, and improve reliability. The system uses standardized waterproof connectors at each branch, making installation and service quick and modular. Components requiring 12 volts receive power from small local converters placed close to the load, which minimizes voltage drop. With electronic fuses and smart current sensors monitoring each branch, diagnosing electrical faults becomes much faster and safer. Instead of tearing apart dashboards or tracing long wiring harnesses, technicians can simply unplug and swap faulty modules, many times even through Tesla's mobile service in less than an hour. This streamlined approach reduces downtime, avoids secondary damage from repeated disassembly, and minimizes the kinds of elusive electrical gremlins that plague older 12-volt systems. Over the long term, this makes the car more dependable and cheaper to maintain. Climate control is another area where Tesla brings simplification and efficiency to the Model 2. The car uses an all-in-one HVAC unit mounted at the front that integrates 4 key functions: cooling the cabin, heating it via a heat pump, dehumidifying the air, and managing battery temperature. Building on Tesla's octavalve design, this compact system routes refrigerant and coolant through a manifold, allowing heat to be shifted intelligently between the cabin, battery, and drive unit. The result is greater energy efficiency, fewer hoses and joints, lower refrigerant usage, and simpler serviceability. Compared with traditional resistive heating, which is energy-intensive, a heat pump can deliver 3 to 4 times greater efficiency, helping preserve range in cold weather. In real-world terms, this means Model 2 retains more of its rated range in freezing conditions, warms up faster in winter, cools down more quickly in summer, and keeps windows clearer with better dehumidification. The integrated layout also makes servicing easier. If a valve, hose, or sensor fails, technicians can access and swap the necessary parts without chasing faults through a maze of plumbing. The cause and effect chain is straightforward: fewer components mean fewer leaks, better efficiency means lower energy costs, and modular service design means less downtime. All these design decisions, modular crash pods, resilient cladding, sealed and serviceable underbody, 48-volt electrical spine, and a consolidated HVAC unit, are part of Tesla's plan to make the Model 2 the first truly mainstream EV. Instead of cutting costs only at the factory, Tesla is focusing on the entire life cycle of the car, reducing the financial and emotional burdens of ownership. By lowering insurance premiums, avoiding expensive accident repairs, simplifying maintenance, and keeping the vehicle durable for years, the Model 2 is poised to become more than just an affordable car. It could be the tipping point that brings electric mobility to a much wider audience. If Tesla achieves its goal of launching by 2026, the Model 2 could mark the moment when electric cars stop being niche or premium products and finally enter the everyday mainstream.